Okay, so now let us consider another example where we have complex eigenvalue and complex eigenvector for a system of differential equations. So again we are given a, let us say, 2 by 2 system of differential equations, and this time we are given a one eigenvalue which is -1 plus 2i and the corresponding eigenvector I and 2 minus 2i, and our goal is to figure out the two real solutions that corresponds to this system. Okay, so what is the first step? The first step is to get the complex solution that corresponds to this eigenvalue, and it equals to e to the lambda t, and this time lambda equals to -1 plus 2i t, and then the corresponding eigenvector is I and 2 minus 2i. Okay. So now as before, let us separate this one into two parts, one with the real component and the other one with the imaginary component, and now I am going to skip one step. So basically you will get e to the 2it which equals to cosine 2t plus I sine 2t. Now the argument of this trig function is 2t and the argument of sine is 2t as well. And then so this is the eigenvector, and I am going to separate this eigenvector into two parts because it is a good practice to separate those two. Then it is easier to figure out the real part and the imaginary part of this entire solution. And if you do that, you should get the real part of this first component is 0, so you should get 0, and the real part of the second component is 2. Okay, so that is the real part of this eigenvector, plus now let us figure out the imaginary part. Imaginary part would be, okay, so we have already factored out I, so then this component should be 1 and the second component should be -2. Okay, great. So now to get these two real solutions, what we need to do is we need to separate the separate the real part of this solution and the imaginary part of the solution. Okay, let us do that. Okay, now if you think about the real part, and real part comes from this e to the -t term and then cosine 2t times this part, the real part of the eigenvector v. So you will get cosine 2t times 0 2, right, then plus, now again remember we are looking for the real part of this complex solution. Of course if you multiply two real parts you will get a real solution, plus if you multiply two imaginary components or two imaginary terms you will get another real part, because I times I equals to I squared, that equals to -1. So if you multiply this component with this one you will get another real term, and that would be, let us say, it will be a negative quantity, it is -1, then sine 2t times 1 -2. I hope you all understood this part. What I did was I considered the real terms that come from this product. Of course this term came from multiplying the two real terms, and this term came from multiplying two imaginary terms. Okay, now let us think about the imaginary part, okay. To get the imaginary part, what we need to do is we want to think about the terms with I. Of course, if you multiply real term and an imaginary term, you will get another imaginary term. So, I am going to write e to the negative t cosine 2t, and then this vector 1 negative 2 plus, okay, and then the second imaginary term comes from this product, because this is a real part, but this is an imaginary part. So, you will get a term with I to be sine of 2t times 0 2. That is it. So, this is a one real solution and this is the second real solution that corresponds to our problem, and if you want, you could simplify this. Okay, I think yes, I am going to draw parentheses. This e to the negative t term corresponds to both terms. Okay, so now if you simplify this part, you should get e to the negative t times, okay, the first component here, the first component is 0, but here we have minus sine 2t, sine 2t times 1, and then the second component equals to 2 cosine 2t, minus times minus becomes plus, plus 2 sine 2t. Okay, and then from this you should get e to the negative t times cosine 2t plus sine 2t times 0. So, we do not have a contribution from this part, and then the second component equals to negative 2 cosine 2t plus 2 sine 2t, and this is your second solution x2, this would be your first solution x1. So, this is the way we solve a problem with complex eigenvalues, and as a summary, what you need to do is, once you found a one complex eigenvalue, find the corresponding eigenvector and then figure out the complex solution that comes from the eigenvalue and the eigenvector that you found. After that, you just need to separate the real part and the imaginary part of the complex solution. Real part will give you one solution and the imaginary part will give you the second solution that are linearly independent to each other. Okay, with this I finished the second case. Next we are going to look at an interesting case where we have repeated eigenvalues. Okay, thank you.